Finding the second derivative implicitly is a common FRQ. That's because it tests multiple skills at once. Implicit differentiation, oftentimes a quotient rule is involved, higher order derivatives, and usually all of that's in the context of finding concavity or classifying extrema, max-min problems. We'll cover those in a later lesson. Let's go through an example. Let's find the second derivative of the following implicit equation. And let's also evaluate the first and second derivatives at the point -3, 4. To get the second derivative, we have to first find the first derivative. Let's differentiate with respect to x. The derivative of x squared is 2x. Don't forget to use the chain rule when differentiating y squared with respect to x. We get 2y dy dx. Over to the right, the derivative of constant is 0. Let's solve for dy dx. Subtract the 2x, divide by 2y, reduce, and we have our first derivative is negative x over y. You may recall this is an equation for a circle with radius 5. At point -3, 4, we know that the slope is positive. Let's confirm that. Let's plug in -3 and 4 into our first derivative. On the top, we get -3, which is +3, and on the bottom, we have 4. So the rise over run is 3 over 4. Let's differentiate one more time to get the second derivative. Let's pull this negative out to the front. Our first derivative is a fraction, so we have to use the quotient rule. Remember the mnemonic: low d high minus high d low, all over the lower function squared. Applying this to our first derivative, now the lower function is y. The higher function is x. Its derivative is 1. Minus the higher function times the derivative of the lower function. The derivative of y with respect to x is dy by dx. All that goes over the lower function squared. At this point, you want to recognize that we know what dy dx is. We solved for that earlier. So let's substitute that in for where we see dy dx. Let's clean up the numerator. Negative x times negative x over y is positive x squared over y. So on the top, that gives us y plus x squared over y. Now let's get rid of the fraction within a fraction. The common denominator on the top is y. That turns the numerator into y squared plus x squared over y. And since all of that is over y squared, that extra y, we can drop it to the bottom. Remember our original equation: x squared plus y squared equals 25. On the top, we have x squared plus y squared, so we can replace that with 25. This is going to be a common simplifying strategy, using the original equation to simplify. So our second derivative is negative 25 over y cubed. Now we can evaluate this at the point -3, 4. On the bottom, 4 cubed is 64. So the slope of our second derivative at this point is negative 25 over 64. We'll learn what this means in a later lesson, but for now, try this one. Find the second derivative of this implicit equation. Let's start by finding the first derivative. On the left side, so don't forget to use the chain rule. The derivative of y squared with respect to x is 2y dy dx. The derivative of 2y is 2 dy dx. Over to the right, we have 8x plus 2. Next, solve for dy dx. Factor, divide through, reduce. Now it's time to take the second derivative. Hopefully you recognize that we need the quotient rule. The function on the bottom times the derivative of the function on the top, minus the function on the top times the derivative of the function on the bottom. All that goes over the function on the bottom squared. Low d high minus high d low, all over the bottom function squared. Do you remember what to do now? We need to substitute for dy dx. We solved that earlier. Let's combine the 4x plus 1's on the top and the y plus 1's on the bottom. And there's our second derivative.